Jerry here, co-founder and CEO of LlamaIndex. For those of you who don't know, LlamaIndex is a developer platform and toolkit for helping you build LLM applications over your data. So the topic of today's talk is basically on building an advanced knowledge assistant. I have like 20 to 30 slides in here, and I have 15 minutes, so I'm going to try to run through as fast as possible. The overall idea of building a knowledge assistant, for those of you who, how many of you are familiar with like RAG? Okay, great. First of all, I love PyTorch. I've used PyTorch since like, way before Gen AI and trained a bunch of models with it. And so I think maybe what I'm talking about in these slides is really how do you actually build applications on top of these models, right? Because I think a lot of traditional ML is on the training of these models, and a lot of Gen AI development has oriented towards how do you actually build principled applications by orchestrating different components together. So part of the goal here is really on orchestrating the right components to build something that's what we call an advanced knowledge assistant. The goal is to build like an interface that can take in any task as input and give back an output over any arbitrary amount of data that you have, whether you're an individual or an enterprise with a ton of data. The input forms can be simple questions, complex questions, research tasks, and the output forms could be short answers, structured outputs, actions, basically anything. The naive RAG stack doesn't really work. If you use a basic text splitter, use top K retrieval, you're going to run into a lot of issues. And what's more is that you're only really using the LLM to synthesize information from the context and not really using it for any sort of more sophisticated reasoning and planning. And this really limits the capabilities of any RAG-based knowledge assistants because it's really only able to surface answers to very pointed questions as opposed to helping you answer really any question over your data. So we asked ourselves, can we actually do more? There's a lot of questions and tasks that naive RAG can't give an answer to. This leads to hallucinations if you have the wrong components. The value add to the end user, the person that's actually using the tool, is not very high because they still need to do a lot of work to go back and forth with this chatbot to try to extract the right information from this AI tool. So how do we actually build something that's more advanced and also production ready and can actually lead to actual productivity gains for the end users? We see this as like 4 main components in terms of building a better knowledge assistant. First, a high-quality data and retrieval modules. 2, agentic reasoning over complex inputs using common agent ingredients. 3 is agentic decision-making and output generation. So instead of just giving you back like a chatbot response, translating it into an action or an actual structured report, like an actual unit of work that you can basically just produce. And then 4, actually deploying these agents in production. So we'll start with high-quality data and retrieval, which is really the base layer. Before you actually add on any sort of agentic ingredients, we think that basically anyone building a production LLM app should have the right data processing modules in place to make sure that your systems and your data are accessible in the right interfaces to the LLM. There's a new ETL stack for LLMs that arose due to the emergence of RAG. And this includes stuff like, given a PDF, you need to parse it, you need to chunk it, and then you need to embed and index it into a storage system. We were especially interested in complex documents. And by complex documents, we mean any document type that has a bunch of like tables, charts, diagrams. And what happens when you try to actually parse this naively is that the text gets all jumbled together, the tables are unreadable, you don't actually parse any information from the images, and the issue is that when you try to ask questions over this data and it's been parsed incorrectly, then no matter how good the LLM is, it's not going to give you back the right answer. Most document parsing is inadequate. So if you use PyPDF, like an off-the-shelf open source like parser, and you try to parse most research reports, it's going to jumble the text. And the issue with jumbling the text is the LLM gets really confused about whether the text and the numbers should align with the right rows and columns, and it leads to much higher rates of hallucinations. So we worked very hard on building this LLM native document parser. An ideal Gen AI native parser can structure these complex documents and actually parse out the complex entities within these documents and feed it into more advanced indexing retrieval algorithms for RAG. So the requirements here include parsing the tables accurately, parsing the text with complex fonts and layouts properly, making sure you're actually parsing out the visual elements on the page, and feeding it into downstream multimodal models. And this avoids some of the requirements of traditional document parsers too. So we built Llama Parse as one of the first items in the stack, and it's a very good document parser, specifically for reducing LLM hallucinations. We just launched Llama Parse Premium today, actually, which combines multimodal models with traditional text parsing techniques. So you can basically point your RAG pipeline to just really, really complex files and still get back structured outputs and good responses. So after parsing, you can combine parsing with hierarchical indexing retrieval algorithms to basically better model all the different types of structured data within the document. So if you have text chunks, you have tables, you have images, you can extract out representations from each of these elements so that they're indexed into a vector database. And then during retrieval, you're going to fetch these representations and then basically dereference them back into the source elements. And this all works even better if you use like a multimodal model, right? So instead, not just like a text-based model, but like GPT-4o, Sonnet, Gemini, the latest models all support multimodal capabilities. And so if you're able to actually index both the text and image chunks of the documents, you can feed both of those into the LLM to get back even better results. Some of the use cases that we see with just very good data indexing and multimodal RAG pipelines is you're able to perform analysis over, like for instance, investor slide decks, annual financial reports with a lot of tables, Excel sheets, insurance claims, form extraction. And these are all very practical real-world use cases that we worked with both our users and our customers on. So putting some links here if you're interested in checking it out. But this is part of Llama Cloud, our enterprise RAG platform. Llama Cloud contains Llama Parse, our document parser. It's an end-to-end RAG platform that helps you set up multimodal RAG in minutes if you don't want to build it from scratch. It's helpful for developer teams to basically centralize their RAG pipelines. Cool. Moving on from data and retrieval is agentic reasoning. So that's the next stage. And a lot of people are interested in agents these days, and for us, we see it as basically, a progression of steps towards building something that's a very sophisticated, advanced knowledge system. The motivation here is that naive RAG doesn't work well for most types of questions that aren't very specific in nature. If you ask a summarization question, a comparison question, a multi-part question, or a general research task, or actually, ask it to perform an action for you, it's not going to do very well. And this is because you're directly feeding in the question into a vector database. You're not doing some sort of query transformation layer in the front. There's a progression of steps you can take to get to something that's maybe a more general agent architecture, like a React agent, or one of the fancier papers that have come out recently. But all these, when you build a full agent systems, it comes at the trade-off of higher latency and cost. And then it's potentially less reliable. However, these general agent architectures are more expressive, so they can solve a broader range of different tasks. We see folks basically building a variety of different types of agentic systems, and if you decide to compose your own agentic ingredients like routing, prompt calling, tool use, that type of stuff, in your own constrained fashion, it typically solves very specific use cases well to start with. And I think that's a good way to start before you compose something that's more advanced on top of it. The concept of agentic RAG is a step beyond RAG where you're basically treating like a retrieval pipeline as a tool. So if you have like a data bank of unstructured data, like documents, files, web pages, you basically have an interface to access and retrieve that data, which is a vector database, and then you use the agent capabilities like tool use, memory, query planning, reflection to dynamically call that tool and other tools as many times as you want, basically, to solve some task. So all these agents come equipped, well, a general agent architecture comes equipped with chain of thought prompting. So you can, given a complex question, break it down into subtasks to then ask against a given tool. And so the end result is that you're able to build a more personalized QA system that can handle more complex tasks from the user and break it down more intelligently to better answer this task at hand. I talked about this a little bit, but there's both constrained flows in agentic systems that we see folks building, which are more reliable and less expressive, and then more unconstrained flows. For instance, a general agent architecture, like a React agent with a bunch of tools, and it will actually, given a task, dynamically figure out the plan to try to solve that task, as opposed to the human, like writing Python code, for instance, to define that plan beforehand. They all have trade-offs. The constrained flows, again, are less expressive. They are cheaper to implement, and oftentimes we see enterprise users basically implement simple agents to solve very specific tasks. There's a certain distrust in more general agent architectures right now, especially in very big, complex multi-agent systems. But we do see that as the models get better, as they're better at reasoning, that these systems where you have agents access a wide corpus of enterprise data, that's going to become more possible. The next section is, in a traditional RAG pipeline, it tends to just produce a text response. And you as a human are responsible for translating that text response into something that's interpretable, to basically solve your task. But if the agent can actually not only just give you back a response, but actually directly perform work for you, that really is the next step. So for instance, report generation is a huge use case. Being able to produce an entire research report, fill out an entire form, produce a slide deck. These are all examples that we're already seeing being adopted within the enterprise. Performing data analysis, visualizations, taking actions like scheduling a calendar invite, sending an email. These are all examples as well. If you can actually do this, this does lead to a huge value add for GenAI, because then the human is not responsible for then going in and trying to make sense of what's going on in the chat response, but actually they're actually able to move to a role where they're able to supervise and give feedback to the AI, as opposed to being directly responsible for producing the final output. So some examples here include multimodal report generation. We have an example in LlamaIndex that helps you, given some research task or some input over a corpus of data, generate an entire multimodal report from that data with a multi-agent researcher and writer setup. This also includes customer support. Actually going in and understanding the customer issue, following either some sort of constrained series of steps, and then resolving the ticket for them, and getting to the steps where you could be assisting an internal support agent too, but actually taking the step of helping resolve that action for the user to minimize the amount of input that the support agent needs to give. And so I mentioned this already, but yeah, this does potentially lead to a higher degree of ROI, but LLMs first need to get a little bit better for true multi-step actions to basically just run continuously. And then, to get there, this also requires adequate human in the loop. So the human can give feedback at the relevant steps. So they can give feedback, for instance, before the agent takes an action. And also basically just being able to control the execution and roll back if necessary. The last thing I'll leave you with is a lot of agents we see these days are built in notebooks, in Jupyter notebooks. And we think about how do you, take this code that's written in notebooks and basically deploy it in production infrastructure. So we think you need the right infrastructure and architecture to basically deploy complex agentic workflows as production services. We want every agent to be modeled as an API interface. It needs to be scalable, so you can add more agents and they can all communicate with each other. There needs to be a standardized communication protocol, and there ideally should be support for services like human in the loop, streaming, rewind, undo, state management, and also debugging and observability. So the last thing I'll leave you with is we have this repo called Llama Deploy, which allows you to write workflows in LlamaIndex as custom agents, agentic systems. And then with a few lines of code, you got to deploy them as microservices. And these microservices communicate with each other through a central message queue. We integrate with Kubernetes, with message queues like Kafka and RabbitMQ. And it's actually under development, so stay tuned. Thank you.